Hey folks, welcome. Today we're going to look at section 10.2.4 from our CPM Common Core Algebra book, and we're going to identify in specifically quadratics how many solutions the equation is going to have. This can be a very, very valuable tool for identifying the number and type of solutions we're going to encounter, which in application, in real-world problems or situation problems, can be pretty gosh darn valuable. Okay, so real fast, over here on the left-hand side, I've got my chapter index. I open up chapter 10, and I scroll down to section 10.2.4. And as we've seen in the past on my iPad, I do have some modified notes, and the focus, as I already mentioned, is going to be how we're going to identify in quadratics the number of solutions that we could have. We're going to start today with with problem 10-60. And I'm going to read, and then we're going to look at a problem, and I'm going to go a bit out of order here, but it says, from problems in prior chapters, you know some quadratic equations have no solutions. Some have only one, and some have two. How can we quickly determine how many solutions a quadratic has? Quadratic equations below are written in perfect square form, okay? And this is a skill that we covered in chapters 8 and 9. Sometimes they call this vertex form. Sometimes they call this graphic form. We have it from completing the square. Okay? It says, with your team, solve the equations below and take notes on how many solutions there are. Express your answers in both exact form and approximate decimal form. Look for patterns among those with no solution and those with only one. Be ready to report your patterns to the class. So here we go. I'm going to start because I know what's coming here. I'm going to start with letter C. And letter C says the quantity of 2x minus 3 squared equals 49. Now, we're going to go ahead and solve this thing. And we might use decimal notation here. We're not going to need it, but, well, that's not true. We might need a calculator. So I've got my handy-dandy phone calculator handy here. It is the 4-function calculator that I'm going to need. So here we go. I'm going to start this thing with getting rid of that square. So I'm going to take the square root of both sides, and I'm going to do this. I'm going to do this, and I've got the square and the square root canceling, and I've got 2x minus 3 equals, and the square root of 49 is 7. Now, check this out. We've talked about before in class the duality of the how to put it, the number of solutions that we could have here, because we know that 7 squared makes 49, but we also know that negative 7 squared makes 49. So we have to consider both of those things. We've got to go ahead and do plus or minus 7, okay? And this might force you to reflect a little bit on something you've experienced recently in prior lessons in chapter 10, which is, in chapter 9, which is with the quadratic formula, we've got the plus or minus as we're doing that solving after we identify A, B, and C. Okay, so now is where I'll break this apart, and I'll say, okay, 2x minus 3 equals positive 7, or 2x minus 3 equals negative 7. So I've got both of those things there, and I'll solve this. The math is pretty gosh darn easy. All right, I've got plus 3, I've got 2x then equals 10. I divide by 2, and then I've got x equals 5, right? I didn't show the division there, but I've got x equals 5. Okay? And then I got here where I'm going to add 3 to both sides, and then I've got 2x equals negative 4. Then I divide both sides by 2, I get x equals negative 2. So I've got two solutions here, and what I notice is in letter C, when I've got my my quantity squared equal to a positive whole number here, specifically a perfect square, I've got two solutions. I'm just going to make that note. Two solutions. Okay? That said, letter C is Dunsky. Let's go ahead and check out letter A. Okay? Let's do it in a different color. Let's do it in green. Why not? Letter A says the quantity of x plus 4 squared equals 20. Okay, so I'm going to go over here, look at letter A. I'm going to solve using the exact same concept here. The square root of both sides, right? I take this, these cancel. I'm left with x plus 4. Now here's where you know, CPM, the book said, hey, do this in a exact form, which would be like the reduced radical, or and in decimal form. And I would actually advise you to do this in decimal form, because one of the things I pushed was the situation problem, the application, which means there's a chance that we're using this in our real life scenarios or settings, and the decimal form, probably rounded to the nearest tenth, is going to be most applicable there. So 20 is not a perfect square. There's not two integer values that multiplied together. There's not an integer value that will multiply by itself gives us 20. So I'm going to go here, type in 20, and then I take the square root, and it tells me, you guys can see that, approximately 4.5. And again, we're dealing with both the positive and the negative. Okay, so look what's happening. I've seen this before. I've got two cases. I've got x plus 4 equals positive 4.5, or I've got x plus 4 equals negative 4.5. Okay, so there we go. I'm going to subtract 4, and I'm not showing this work, and I get x equals 0.5. I'm going to subtract 4, and I get x equals negative 8.5. If you are not sure, show your work and check those to verify that I've done that correctly. But what do we have again? I've got two solutions. Oops, that's not the right two there. Sorry. Two solutions. And when did that happen? Well, I've got a positive value that the quantity squared was equal to. Okay, so that's interesting. But it wasn't a perfect square, which is why I had those decimals. Okay, so A is done. All right, let's go ahead and look at letter D. Let's look at letter D here. Letter D says the quantity of 5 minus 10x, get rid of that goofy looking little apostrophe there, 10x squared equals 0. Now, the reason I chose letter D is because that equals 0 looks a little like weird to me, okay? So let's go ahead and do some solving here. We're going to take the square root as we've done already. Square root there, yay, okay. Now check this out, because the square and the square root cancel, and I'm left with 5 minus 10x equals, and what's the square root of 0? Well, as we've seen before, this could be plus or minus 0, because when we do that, again, we're considering the positive value that makes, when multiplied by itself, the positive whole number, and the negative value that when multiplied by itself makes the positive whole number. But 0, positive 0 and negative 0, it's just 0. There's no positive or negative, right? So I really don't even need to consider that case. There's only one of these things. Now that's going to play into how we do this. Watch this. I'm going to subtract 5 from both sides, and I do that, and I get 10x equals negative 5, and then I divide both sides by negative 10, and I get x equals positive 0.5. Check this out. I've only got one solution here. All right, so look at that. I notice when I've got 0, I've got that quantity squared equal to 0, I've only got one solution. So when it's equal to a positive number, I got two solutions. When it's equal to 0, I got one solution. Okay, let's check one more case here. And I'm intentionally picking on letter B here. We're going to tackle letter B, and I'm going to write down over here, I've got the quantity of 7x minus 5 squared equals, I've got negative 2. Okay, so letter B is the first time I'm seeing a negative value. I've got that quantity squared equal to a negative value. Let's take a run at this. Let's see what happens. We're going to solve using the exact same sequence, right? I take the square root of both sides. I've got 7x minus 5 equals, square root of negative 2. Let me see. Like, I know I can do the square root of 2 in my calculator, but as a reminder, if I just grab my calculator and I type in 2 and I make it negative, and then I go to take the square root, right? I'm not just bad at doing stuff in my calculator, right? I'm not just bad at it. That's not possible, right? Some of you guys may have heard of an imaginary solution before. I'm sorry, an imaginary number, but what the heck's happened? We can't do that here. Not with our current level of understanding in our number system. So unfortunately, we've got to say this one's got no solution. And I want that to be our takeaway here. when we've got positive, when we got this quantity equal to positive values like we do in A and C, we're going to have two solutions. Okay, now if it's a perfect square, we're going to have those nice integer solutions. When it's not a perfect square, that's when we're going to get those decimal values, like in A. When we've got it equal to 0, like in letter D, that's going to give us one solution. That's going to yield one solution. And then finally in B, when it's equal to a negative value, we've got no solution. Okay? And we're going to go ahead and do this here, and we're going to do some quick determining here of the number of solutions that we've got in problems A, B, and C in 10-61 here. It says use the the patterns we just identified to quickly determine how many solutions there are for each quadratic below. You don't need to solve. Well, ladies and gents, let's do this. I'm going to start with letter B because look at that. That's that quantity squared in perfect square form. It's equal to 0. And because it's equal to 0, when I take that square root of 0, the square root of 0 is 0. It's no plus or minus. So this is going to quickly let me know that I'm going to have one solution. Okay? I'm going to slide over here to letter C. Now this one might look a little backwards because, you know, I've got that quantity squared. It's on the right-hand side and the positive value on the left-hand side. Okay. Doesn't matter, though. I could switch it around if it made me more comfortable. But this is going to be the case where because the 11's positive, I have two solutions. Okay, so that's looking pretty good. Because that 11 is not a perfect square, it is not going to give me integer values for solutions. It's going to give me decimal values. So taking it above and beyond, that's something we could check out there. And then finally, letter A. I mean, look at letter A. Letter A looks like they're trying to throw me that massive curveball, but we're not going to fall for that. I mean, I'm seeing the 0 on the right-hand side there. So instantly I want to say, hey, one solution. But I don't have that quantity squared isolated on the left-hand side, which means to me, I should take this 6 and I should move it over using that inverse operation of subtraction. And now what in the heck do I got? Well, I got 5m minus 2, that quantity squared, and that's equal to negative 6. Whoa, okay, so that changes things. That means for me, I am going to have, for this particular case, because that 6 is negative, I'm going to have no solution. Okay? Because we can't take the square root of that negative value and come up with a real number. All right? One of those things we're going to go ahead and run into again and again. Okay, a couple more problems here. How many solutions do we have below? How can you express the solutions? Well, ladies and gents, you're like, oh man, Anderson, there's no number over there on the right. Well, remember, we don't solve these things when they're equal to y. We have to set them equal to 0. So if I was going to do b first, I was going to go like this and set it equal to 0, and then I was going to say, oh, yeah, okay, I got 0 all by itself on the right. I've got that quantity squared, 3x plus 1 squared, isolated on the left-hand side. I could take the square root. I'd end up with one solution here. All right? If I jump back to a, I'd set this equal to 0, 9x plus 9x squared plus 4x minus 6 equals 0. And then I could go ahead and I could do some factoring. Now, whether or not I wanted to factor, I could complete the square. Okay? And here's what I'm going to go ahead and do. I'm going to say, pause the video right now, because I'm going to pause the video. I'm going to complete the square, and then we're going to look at the number of solutions. Okay? All right, I went ahead and completed the square. How did you do? I started by adding 6 to both sides. And after I did that, I recognized that I have to get rid of this coefficient of 9, so I divided everything by 9. Then I decided to leave all of my numbers as reduced fractions. So I had x squared plus 4/9 x equals 2/3. And then I took half of that b term, squared it, added it to both sides. That's what's happening here and here. I did that in pink. Then I could write it in perfect square form. My perfect square is x plus 2/9 squared equals this stuff over here on the right-hand side. Now, believe it or not, that's all the further I needed to take this, because I recognize that that's going to be a positive value. Really, who cares what it is? I've got that quantity isolated on the left. I've got a positive value on the right. That tells me everything I need to know about this problem. I'm going to have two solutions. Ladies and gentlemen, just a little bit of review preview here, 67 to 71. Try these things. They help uncover questions, and then it's your job to follow up on those questions. Thanks for watching. Have a great day.